Mhm. Hello everyone. Welcome to India's largest e-learning platform, Gradeup. Tell me guys, how are you? Tell me who has joined the session and how are you guys? Are you preparing for your Vizag exam? Yes or no? We at Gradeup are bringing daily questions for you for your Vizag exam. Are you preparing or not? Tell me. Okay, let's everyone join the session. Let's say everyone join the session. So quickly guys, join the session and tell me who has joined the session. Everyone, tell me in comment section who has joined the session. Okay, so let's start our today's class. So guys, today's class is going to be very special because today we are going to see the questions on power system, one of the most anticipated subjects for the electrical engineer students. Today we are going to see the power system. Sorry for the wrong subject name. So let me change the subject name very quickly. Let me change the subject name. Actually, it's not network theory, it's the power system. Let me change it very quickly. Okay, good, fine. Okay, hi triple R, hi, hello. How are you guys? Okay, so let's start our today's class. So let me introduce myself first. My name is Ishaan Mudgal. I have a 3+ year of experience, 5 times get qualified, MTech gold medalist from NIT Allahabad, and these are my areas of expertise. And guys, I have already taken the network theory lectures for the Vizag exam. I hope you have already seen that. Okay. Apart from network, Ashutosh sir has taken the machines class. So I hope you all have followed that class also, because machines, power system, networks are very important for your exam. Okay, many questions will ask from this exam. Okay, so let bring your friends also guys. जितने ज़्यादा बच्चे होंगे उतना ज़्यादा आपको भी मजा आएगा, मेरे को भी मजा आएगा. So let's start our today's class. So today's first question is this. Everyone is going to give me answer in a comment section. If you don't provide me answer, it means you don't know the concept. Okay, and the exam is just few days ahead. Okay, 13th December is your exam. Okay, so everyone give the answer for this particular question. We will start from an easy question, then we go to a moderate question, then we'll increase the level one by one. Okay, and 2 days we have a class on power system. So I want everyone to give the answer for this particular question. Okay, in 2 days, in today and tomorrow, we are going to cover at least 60 to 70 question. Okay, good. So triple R given answer A. Bablu Castle has given the answer A. Everyone, many people are online right now. I need answer from each one of you. So question is, in India, the transmission of electrical power is done by. See, transmission of electrical power is done by three-phase, three-wire system. Correct. Three-phase, three-wire system. But tell me, bacha, where we should use three-phase, four-wire system? You should understand where we use every different system. Okay. In transmission, we use the three-phase, three-wire system because transmission of electrical power is balanced. When we talk about a transmission line, almost balanced power will be transferred from one point to another point, and transmission is from the generation to the substation. Okay, so tell me where we should use the three-phase, four-wire system. Hello, Prabha. Pundalik, no beta, your answer is wrong. Okay, triple R saying distribution system. Okay, chalo. If I talk about the distribution system, so we have a two type of distribution system. First one is a primary distribution. And second is secondary distribution. So now tell me specifically in which distribution system we use the three-phase, four-wire system. In which specific distribution system we use the three-phase, four-wire system? See, three-phase, four-wire system is basically used in the primary distribution, in which you require a voltage level of 66 to 33 kV. Okay, and why we use the four-wire system? The fourth wire or a neutral wire is used because now a primary distribution contain a load. Which type of load? For example, it has a factories. it has a factories, it has a mining industries. Okay, these type of loads create the unbalance in the system. That's why a fourth wire, or you can say neutral wire, is required in this type of system. Secondary distribution has a range of 400 to 230 volt. Okay, means 400 volt is used in a IT companies, or you can say any type of company that in your city. 230 volt will be used by your residential area. So basically, one phase system will be used in a residential area, whereas three phase 4 wire system will be used in a primary distribution, for example the factories, mining, etc. Apart from this, you have a DC system also. Okay, so you should understand every application of every system. For the examination, it's very important. One mark, one question can definitely come from this particular topic. Right, now next question. Sorry guys, sorry. And guys, like the session. Right now 22 people are online and only 11 likes. Everyone like the session. If you like the session, that is your attendance. Okay, and share this lecture with your friends, with your study group, so that they can also join the session and they can benefit it from this. So everyone, tell me about this particular question. Okay, again, this is also a basic question, but most of the students get confused in this question because of the first line I have written here, which is what? By keeping the power loss constant. By keeping the power loss constant. This line is very, very important to give the answer for this question. Hello Yashwan, good evening. How are you? Okay, so Mahesh has given the answer. Good. Tapas has given the answer. Okay, let's see. See what is given. First of all, you should understand this line. If this line is not mentioned, then the answer will get changed. By keeping the power loss constant. So first of all, what is the formula of power? If I talk about the AC power is given by VI cos phi. Okay. Now from here, I can find out the current is P divided by V cos phi. Why I am finding out the current? I am finding out the current because I want to find out the power loss. Power loss formula is nothing but equal to I square R. So from here, if I put the formula of current, it becomes P square V square cos square phi multiplied by R. Okay. Now here in this question, they have given the power loss is constant. So what I am going to do, I am finding out the R from this equation, and you will see the equation will look like this one. P square. Okay. Now what is resistance? I need to find out the size of a conductor. Always remember, the size of a conductor is basically told by its area. Okay. In some book you will say volume also. Okay. Why? Because volume is nothing but area multiplied by length, and length is always remain constant. So you can either take volume or area, the result will be same. So from here, I can find out rho L by A is equal to V square cos square phi multiplied by loss power divided by P square. From here, what is the formula? What is the area? Area will be rho L P square divided by V square cos square phi multiplied by PL. Now listen very carefully. Power loss is constant. Resistivity is going to be constant, length is constant, and we take the real power to be constant whenever we need to find out the size of a conductor. So area is directly proportional to what? 1 divided by V square cos square phi. Now see the options very carefully. Area is nothing but a size of conductor. Okay, so size is increased by n times by increase the voltage by n time. Wrong. If you increase the voltage n time, the size become 1 divided by n square. It means reduced by n square. Okay, it's wrong. It will be reduced by n square. It will be reduced by n square times by increasing the voltage n time. Similarly, if you talk about the power factor, if you increase the power factor n times, then again it will reduce by n square times. But remember, if this statement is not given, then area will be directly proportional to 1 by V. Remember this thing. If this statement is not given, the area is multiplied by directly proportional to 1 by V. Very, very important. Okay. I hope you know this particular concept. That's why this line is very, very important. Okay. And guys, if you have any doubt, you can ask me anytime. You just ask me. Okay. So Shakir has given the right answer. Yashwant, I am also fine. Thanks, Prabha. Now, tell me this question, everyone. Very simple question again. Just the basic knowledge you require. And beta, don't think about the Vizag paper is going to be tough. No, Vizag paper is going to be easy. Okay, you just need to focus on basics. And you know, when you have more number of questions, the numerical will be less because numerical will take much time. The numerical will surely come. It will not happen that the numerical will not come. Numerical will surely come, but the length of numerical, the level of numerical will be very, very less if you are compared with GATE exam. Okay, GATE exam is a different thing. Your Vizag is a different thing. Okay, so prepare for that particular exam for which you are going to give. So in this question, okay, only one student has given the answer. So Vishwanan has given the option B. Okay, Vishwanan, good. Everyone give the answer. There is no negative marking right now. Okay, यहाँ पर negative marking नहीं है. In exam you will face the negative marking, but here you should give the answer. Okay, Pundalik is given the option B. Good, good. Everyone, in a 3-wire balanced DC system, the voltage between outer conductor and neutral is V. The voltage between the outers is. So let's see. Okay, okay. Now listen this thing very, very carefully. 3-wire balanced DC system. What is the meaning of 3-wire balanced DC system? A 3-wire balanced DC system representation will be like this. This is the neutral wire. This is first wire. This is second wire. Okay. Eraser. Okay. And here I can write this is plus minus and this is also plus minus. Okay, fine. So this is the first wire, this is the second wire, and this is the third wire. And beta, for your general knowledge, for one important information you should know, area of neutral wire is always 1 by 2 area of main lines. Main lines means, for example, for this particular line area is A, then area of neutral wire, this wire, will be 1 by 2 times of area of A. Remember this point. Okay. Now what is the question? The voltage between the outer conductor and neutral is V. Voltage between the outer conductor and a neutral is V, like this. The voltage between the outers is, what is the outer beta? Very, very easy. Outer wire is this wire. So what is the voltage here? Just apply the KVL. Apply the KVL, you will get the outer voltage is equal to 2 times of V, not 3 times of V. It will be 2 times of V. Okay, why? Yashwant has given the right answer, but most of you has given the option B. Why बच्चों? Why बच्चों? Okay, आप लोगों ने B answer क्यों दिया? And only one student has given the option A. Now tell me your thinking. What did you think? I want to see what did you think. Why did you give the answer 3V? Everyone tell me. They are asking what is the voltage between the outers and the voltage between neutral and the third wire is given. Okay. Now like the same question, I am giving you one more question. For example, I have a 4-wire AC system. I have a 4-wire AC system. Okay, just for another example, I have a 4-wire AC system. So what is the 4-wire AC system? The 4-wire AC system will be like this. Now I am telling you the voltage here is V. Okay, now I need to find out the voltage across outer. Tell me for this question. Everyone, tell me for this question. This is a 4-wire AC system. The voltage between outer and the neutral is V. I need to find out the voltage between the outers. Tell me for this system. Again, I want to check your basics. And this is the basic going to use in every exam. Whichever exam you are going to give, this basic is going to be used everywhere. Okay. So tell me, what will be the voltage at outer? Everyone, try karo. Okay, so Yashwan has said 2V. Okay, Yashwan. Okay, Yashwan. Anyone else? Anyone else? Think about it, Brida. Think about it. Answer is not 2V. Answer is not 2V. Think about it. Correct. Abhishek is correct. Abhishek is absolutely correct. See, beta, this is 4-wire AC system, and this voltage V is nothing but a phase voltage. This is a phase voltage. What is the phase voltage? Phase voltage is the voltage between the wire and a neutral. And you know, in a 3-wire system, what will be the line voltage? Line voltage is the voltage between two outers. It will be root 3 times of V. Remember, this is an AC system. Okay. Okay. And if you apply the KVL here, your KVL will be wrong. Why? Because always remember, in case of AC, the KVL will be applied in case of a phasor quantity. This is a DC system. So you just apply the KVL like the magnitude. But here you should see, if this is V angle 0, then this will be V angle 120 according to the balance system. Then you should apply the KVL and you will get the same answer, root 3 times of V. And I told you about this thing. Whenever you are going to apply the KCL or KVL in case of AC system, you need to sure that it should be in phasor quantity, not in magnitude quantity. Okay, good. But attempt karo. If you attempt the question, that is a bigger thing than giving the right answer. Okay, because if you are not giving the right answer, you are going to learn something. Okay, now next question. Now this is the most easy question. Just you need to understand one line which is written here. If you understand that line, then this question is nothing. So just crack this question. Okay, just attack on this question and defeat it. Everyone, read the question carefully and give me the answer A, B, C, D. Only one particular line is important here. If you understand the meaning of that line correctly, then this question is just a piece of cake. Okay, so everyone try karo. Everyone try. And I need answer. I don't want that everyone should give the right answer. I want that everyone should at least give the answer. Okay, think about it. What is the question? A DC 3-wire is to be converted into 3-phase 4-wire system by adding a 4th wire equal in cross section to each outer of the 3 DC system. The percentage power loss and the voltage at consumer's terminal are to be same. Okay, means the receiving end voltage is equal to the sending end voltage. That is written in this particular line. Assume loads to be balanced. What is the power loss in the neutral wire? Okay, okay, Mahesh good, Kumar good, Yashwan good. आप लोग आंसर दे रहे हो. Everyone should give the answer. Everyone should give the answer. Okay. And guys, like the session. Still, the more people are online and session is liked by less people. Everyone should like the session. Okay, so let me tell you the answer for this question. The answer for this question is lies in this line only. This line, very, very important line. Assume loads to be balanced. Whenever you have a balanced load, the neutral current is going to be 0. Always remember this. A current in neutral can only be flow if you have an unbalanced load. But if you have a balanced load, neutral current is going to be 0, or you can say I1 plus I2 plus I3, which is a 3 line, or you can say IA, IB, IC, phasor quantity is equal to 0. Always remember. And if current in a neutral is 0, the power loss will be 0. Option B. Option B. Okay, many people has given the right answer. Golda, Priyam, good bacha. Mahesh, good. Mitlesh Kumar, good. Okay. Okay. So remember this point. Balanced load में neutral में current flow नहीं करता. There will no current flow in a neutral in case of a balanced load. Okay. Now this question, a very easy question again. A very easy question, but here you will revise the important concept of power system. Correct, Jayant, your answer is correct. Satya, your answer is correct. B option, absolutely correct. Now, the high voltage DC transmission, which is HVDC, is better than HVAC because of. And guys, today we are going to solve 35 question, beta, 35 question in 1 hour, which is which is going to be very useful for your exam. Okay, and in 2 days we are going to solve 70 plus question. Yes, electrobot. Yes, electrobot. Balance means that there will be no flow of current in a neutral. What is the meaning of balanced current? Balanced current means the magnitude of all the current is same, but they are lagged by 120 degree. There is a phase shift by 120 degree, and if you add up all of this thing, it comes out to be 0. Okay, Prabha and Brahma has given the option B, and Satya, Mahesh, Jayant, Ramadeshu given the option D. So let's see. We are talking about HVDC transmission is better than HVAC transmission. Why? First of all, we are talking about DC. In DC, the inductance and capacitance effect is not there. Why? Because in DC, inductor change into a short circuit and capacitor change into a open circuit. Okay, and you know, for a transmission line, inductor lies in a series and capacitor lies in a parallel, in shunt branch, not parallel, but in a shunt branch. So whenever there will be HVDC, what will happen? The inductor will get short circuit and the capacitor get open. So there will be no loss because of the inductance and capacitance. Absence of skin effect, absolutely correct. Absolutely correct. There will be no skin effect. Skin effect will only be done in case of AC. Now, what is skin effect? That we are going to understand in upcoming questions. Better voltage regulation, yes. If there will be less voltage drop in inductance and capacitance, then there will be better voltage regulation. The receiving end voltage will be much close to sending end voltage. Okay, but if there is inductance and capacitance effect, there will be drop in this particular elements. So yes, HVDC has a better voltage regulation. So what is the answer? All of the above. Okay, correct. Many students has given the right answer. Now see this question very carefully. This question is simple, but my motive to bring this question is that many students give wrong answer because they don't think properly, or because they want to solve this question very quickly. They want to solve this question very quickly. That's why they given the wrong answer for these type of question. Okay, because I have seen many students to give wrong answer for these simple questions. Okay, so solve this question carefully, read the question, read every option, and then give me the answer. And I want everyone to give me the right answer. Increasing the frequency of a transmission line will, what will happen to the every element that is given according to increasing the frequency? Tapas Veda, for the power electronics, I am bringing the question from the 9th December. 9 and 10 December is going to be 2 classes on a power electronics for the Vizag exam. Okay, and beta, if you want to prepare power electronics for your GATE exam also, we have already started the session there in our other YouTube channel, which is specially created for the electrical students. The name is GATE EEC Impulse. There you can see the comprehensive course, no, not comprehensive, the crash course for the power electronics, where you can understand each and every concept carefully. Okay, but for this question, some students are giving the answer, but still the answer are not correct by some students. So let's see the question very carefully. What is the meaning of shunt capacitance? Okay, shunt capacitance. First of all, we talk about the resistance. Okay, resistance doesn't impact the frequency, doesn't have any impact on resistance. Okay, frequency impact is going to be only over the inductance or the reactance, only on the reactance. It's not going to affect the resistance. So option B and option C is wrong. Okay, now next, if I talk about the line reactance, and actually the options are wrong, it is shunt reactance. If I talk about the line reactance, the line reactance formula is J omega L. Okay, so if you increase the frequency, the line reactance will increase. Okay, it means option D is wrong. What is shunt reactance? The shunt reactance is nothing but a parallel capacitor, and the parallel capacitor reactance is equal to 1 upon omega C. So if you increase the frequency, the shunt capacitance will decrease. Okay, so I guess none of the option is correct. Okay, the options are wrong. My fault. My fault. The options are wrong. I will write here decrease the reactance. Decrease shunt reactance. The option are wrong. Don't worry. My fault. Okay, so what happen here? If you increase the frequency, what will happen? Your shunt reactance will decrease. Okay, and one point very important: frequency affect the reactance. It doesn't affect the inductance or the capacitance. Okay, why? Because what is the formula of inductance? Formula of inductance is 2 into 10 raised to power minus 7 ln GMD divided by GMR. Okay, there is no any variable for frequency. For capacitance, the formula is 2 pi epsilon naught ln GMD by GMR. Again, there is no variable for frequency. So remember, frequency is going to affect the reactance, not the inductance and capacitance. Okay? Okay. My fault, bacha. Don't worry. The option is not A, B, C, D. Its option is E. Okay. And Golda is asking, sir, please give the channel name for the GATE exam. Beta, we have created the channel specially for the electrical and EC. The name of a channel is GATE EE and EC Impulse. GATE EE EC Impulse. And there I have already taken the 7 classes on power electronics where I have revised all the concept of power electronics. Okay. So this is going to be an important channel for electrical and EC. Okay. Correct. Any doubt in this question? Anyone has any doubt in this question? Okay. Correct. Fine. Next question. Okay. Next question. Remember again, I'm again repeating myself, bacha, that frequency is going to affect the reactance. Either it can be your line reactance or the shunt reactance. Second point, it's going to affect the charging current. Okay, but it is not going to affect the inductance, capacitance and resistance. Fine. Let's see. The characteristic impedance of a cable. What is the meaning of characteristic impedance? So what will happen here? What will be the answer here? Okay, Tapas has given the answer. Good. Keep it up. Everyone attempt the question. Abhishek has given the answer. Very good. Sumit Rai has given the answer. And all of these 3 students has given the same answer. Let's see. What is the meaning of characteristic impedance? Can anyone tell me the formula of characteristic impedance? Okay, can anyone tell me the formula of characteristic impedance? Vikrant, you are saying JEE old question paper solve. Beta Vikrant, everything is available. Beta, download our app, download our Gradeup app and follow me and follow the Manoj sir. And you will see we have already solved the old question paper of JEE as well as AE. Okay. Download the Gradeup app, follow Manoj Singh sir, and follow me also. Okay, and you will see all the old JEE paper plus AE paper are solved by us. For the UPPSC exam, for Rajasthan JEE exam, okay, for SSC JEE exam, we have already solved all the old question paper. Just download our app, okay, fine. So let's see. Prabha has given the answer. Correct. The answer for this question is option D. Correct. See, first of all, the answer you are giving, that characteristic impedance is equal to under root of L by C, is not correct. Okay, it is wrong. It is actually the surge impedance. It is actually the surge impedance, which is root of L by C. What is characteristic impedance, bacha? Characteristic impedance is equal to R plus J omega L plus G plus J omega C. Now, when you do the lossless line, when you go to the lossless line, then what will happen? In a lossless line, there is no resistance, there is no conductance because there is no loss. So it converts into L by C. Okay, remember this point. Difference between characteristic impedance and the surge impedance. Characteristic impedance and surge impedance. Okay, this is very important. Difference between characteristic impedance and surge impedance. Okay, So I can say a surge impedance is equal to the characteristic impedance of a lossless line. Fine. So first of all, it will does not impact the length. It will not increase with length. Why? Because if you multiply the length above, you have to multiply the length in denominator also. It will cancel out each other. First of all, okay. Increase with voltage? No, because characteristic impedance only depends on the physical parameters of the line, which is the resistance, inductance, G and C, and none of them depends on a voltage. But tell me about the frequency. Does the characteristic impedance will affect by frequency? Okay, Shamak is saying root over input impedance and the output impedance. Correct. That is also correct. But tell me about frequency. Will it be affected by frequency? We are talking about the characteristic impedance. We are not talking about the surge impedance. Okay, difference between these two things. You need to understand the difference between two things: the characteristic impedance and surge impedance. Will it be affected by frequency? The answer is yes. It will be affected by frequency. Why? Why? You have a frequency term. You have a frequency term. That's why. So here the correct answer is option B. And I knew that then many of you will give the option D. Why? Because you are giving the option for the surge impedance, not about the characteristic impedance. You are giving the option for the surge impedance, not about the characteristic impedance. Okay. Now, if I change this question like this, the characteristic impedance, if I change this question like this, the characteristic impedance of a lossless line, of a lossless cable, we are talking about cable now, of a lossless cable. Okay, then you can say the option is D. Okay, remember this point is going to be very, very important. Very, very important. Okay, fine. Next question. Next question. Again, basic question. Just require your knowledge of a basic and you can solve this question. Everyone solve this question. And we have already passed the half an hour. Okay, we have already passed the half an hour. Just a few minutes left for today's class, and then this class will be over. Okay, just I will take 20 more minutes for you. Don't worry, then you can sleep well. But better, if you are giving the Vizag exam now, you should practice more. You should practice more, and we at Gradeup are regularly providing you many questions to practice. You need not to open any book for that. Okay, and even if you need more practice, download our app. There is a free content, and you can see many videos by me, also by different electrical faculties. So Mahesh has given the answer. Correct, Mahesh? Absolutely correct. Anyone else? Anyone else? Arjun Dev has given the answer. Okay. Chinnang, sorry for wrong pronunciation, but Chinnanangi is given the option D. Okay. Let's see. What is given? The capacitance between the conductance of a single phase two-wire line is C. The capacitance between one conductor and a neutral point between them is. Think about it. It will be A option or a D option. It will be A option or a D option. Think about it. You need to find out capacitance between one conductor and a neutral point. See, capacitance of a neutral is given by 2 pi epsilon naught ln GMD divided by GMR. And capacitance between a line. So, let's suppose you have two conductors AB. Then it is equal to pi epsilon naught ln GMD divided by GMR. So when you compare these two equations, you can see the capacitance to a neutral point is 2 times of capacitance of the line. Okay, correct. Option D. Everyone is correct. Next question. In AC system, the skin effect is. Now we will talk for a few minutes about the skin effect. Okay. First of all, you should know what is the skin effect. See, beta, skin effect is very, very prominent effect in your AC system or in your transmission system. Okay, why? What happens in a skin effect? See, let's suppose this is my conductor. This is my one single wire from which the current is flowing. Now, according to the electromagnetic induction, the eddy current will generate inside a conductor. A eddy current will generate inside the conductor, and the direction of eddy current will be such that inside the conductor it opposes the current, it opposes the operating current, but on the surface of a conductor it will not oppose the current, it will increase the current. Okay, so the resultant current will be, so what will happen, the resultant current will be less inside the conductor, because here the current will be I minus IE, and in the outer conductor, in the outer surface, the resultant current is I plus IE. So what is the skin effect? In a skin effect, that most of the current will flow to the outer area of a conductor instead of the inside area of conductor. Okay, now what is the, and this skin effect is dealt by the skin depth. So if anyone asks you in some interview, if any interviewer is asking you why the skin effect is happen, the answer is because of the creation of the eddy current. Because of the creation of the eddy current. Because if the eddy current is created inside the conductor, they will oppose the operating current. But on over the conductor or over the surface or near the surface, they will not oppose the operating current. That's why inside a conductor you have a less current, and if you have a less current, this will create a eddy frequency. And because of the eddy frequency, reactance inside the conductor will increase. Okay, and you can also say resistance will increase. And which resistance? Effective resistance. Obviously, if there is less amount of current in some area, the effective resistance and the reactance will be more, and due to this the power loss will be high. So what will happen here? The answer is all of the above. Now reduce the effective area of conductor. Obviously beta, now the current is flowing out in outer surface of a conductor, it's not flowing inside a conductor. So obviously effective area is going to be reduced, and due to this resistance is increased, due to this power loss will increase. Okay, got my point? Okay, so option C, some people have given the option C, but beta option is answer is option D, all of the above. Okay, any doubt here? कोई भी doubt है बच्चों पूछ लेना. If you have any doubt you can ask me. Now solve this question everyone. The diameter of a round conductor is 1 centimeter. Its GMR is. So let's take this question homework. I want you to solve this question in homework, and the number is question 1. And solve and give the answer in a comment section. I will give you 5 to 6 questions for the homework. This is the first question for the homework, and I want answer for this question in a comment section. Okay, next question. Everyone solve the next question. But I will tell you the answer is not 0.7788. Okay, Arjun, the answer is not 0.7788, and everyone who is giving the option C is not the answer. But let's see. I gave you one small hint. And guys, everyone like the session and share the session with your friends. Now next question, and I want answer in the comment section. Satya beta, how will the power loss be more? Because beta, the resistance is going to be increased. If you increase the resistance, the power loss is also directly proportional to R. Right? So there will be a power loss. That's why. Okay, the current is reduced. See what will happen. If you see about the skin effect. Then you are providing this much amount of current. Okay, just let's suppose you are providing this much amount of current, but all of this current is going in the outer area. It doesn't mean the level of current is reducing. The level of current is reducing inside the area. For example, if you have a long wire, you are providing a 10 ampere, then here you are also getting a 10 ampere. But in skin effect, what is happen? This 10 ampere is flowing on the outer surface, and due to this the loss will be increased because of increasing of resistance. The current inside the conductor will be less, but the current will be present in the outer surface. It doesn't mean that current will reduce. Okay, जितना current आप pass करो उतना तो आएगा ही ना बेटा. Fine. Define the skin effect. Definition of skin effect. Beta, simple definition of skin effect. Think about it. What is the definition of skin effect? The skin effect is the phenomena in which the current will flow on the outer surface of a conductor instead of inside the conductor, and this is due to because of unequal distribution of the frequency phenomena. And does the skin effect happen in DC? The answer is no. The skin effect does not happen in DC. Why? Because in DC there will be a equal distribution all over the surface. So there will be a current which is spread all over the surface. Unique way, not unique way means they will be distributed commonly all over the surface. Okay, fine. Now this question. In a three-phase transmission line, use 1.24 centimeter diameter of conductors. Okay, so radius will be 1.24 divided by 2 equal to 0.62 centimeter into 10 raised to power minus 2 meter. They are placed at the corner of an equilateral triangle of side 2 meter. Okay, the inductance per phase. Now you can see this is the equilateral triangle. This is the equilateral triangle. So you remember what is the formula of inductance? Inductance is 2 into 10 raised to power minus 7 ln d by r in case of an equilateral triangle. In case of an equilateral triangle. So here I can write 2 into 10 raised to power minus 7 ln 2 divided by 0.62 multiplied by 10 minus 2. So let me use the calculator. Okay, let me use the calculator, everyone. So the answer will be I guess answer will be acha, okay, one more point beta, one more point I forget to tell you. One more point. Here I need to find out inductance now. So here it will be R dash. Here it will be R dash. What is R dash? 0.7788 into 0.62, and here it is 10 raised to power 2. Okay, so 200 divided by 0.7788, and don't forget this 0.7788. It is very, very important. Okay, so answer is 12. Answer here comes out to be 12.05 into 10 raised to power minus 7 Henry per meter. Okay, the answer is option A, Henry per meter. Okay, the option is answer A. Okay, yes, electrovolt 0.7788. Don't forget this number. Okay, in inductance it's going to be very, very important. Fine, the answer is option A. So electrobot has given the right answer, but Prabha and Mahesh, beta, answer is not correct. Answer is not correct. Prabha and Mahesh, the answer is not correct. Beta, calculation. Don't do the calculation mistake. Now next question. Now in this question, I specifically bring this question because of the unequal distribution. Because of the unequal distribution, or you can say the triangle is not equilateral. Now tell me the answer for this question, everyone. Okay, what they are asking, now give me the answer for this question. So we have given a three conductors of a three-phase line are arranged at the corner of a triangle of side 2 meter, 2.5, 4.5. The conductors are regularly transposed. Very, very important line. The conductors are regularly transposed. Very, very important line. And the diameter of each conductor is 1.24 centimeter. So let us suppose D12 is 2 meter. It is 2.5 meter. This is 4.5 meter. Okay, if they are regularly transposed, it means you can give any length to any distance. Okay, so tell me answer for everyone. I need answer for this question. Okay, at least attempt it. At least attempt it. At least attempt this question, everyone. Okay, they are asking you for the what is the equivalent equilateral spacing. If I convert this particular triangle into equilateral triangle, what will be the spacing? And that will only come if your line will be transposed. If your line is not transposed, then you cannot find the equivalent equilateral spacing. So beta, remember, it will be geometric mean of these distances D12, D23, D31 raised to power 3. Geometric mean of these distances. Okay, so it means 2 multiply by 2.5 multiply by 4.5. Let me use the calculator very fast. So it comes out to be 2.82 meter. But I need to find out in centimeter. So 282 centimeter. Option B. Option B. So Prabha, Electrobot, Pritam has given the right answer. Bablu also given the right answer. Beta, आप लोगों के basic बहुत अच्छे हैं. Well done. But don't worry if you are not giving the right answer, other students, don't worry about it. You are learning a concept. You are learning a concept. Okay, and that's more important than given the right answer. Okay, so distance. If see this line is very important. If this line is not written, then you cannot find out the equivalent equilateral spacing. Because of the transpose, it is possible. Now, in the same question, the question is same. You need to find out inductance per phase per kilometer. Okay. So the question is same. You need to find out inductance in per phase per kilometer. Okay. Now find it. Everyone find it. I will use the calculator. You will find it. Everyone find it. Okay. I'm also finding by using calculator. Okay. What is the formula of inductance? What is the formula of inductance? Inductance is 2 into 10 raised to power minus 7 ln d by r. And it will be used when you have an equilateral triangle. So for an equilateral triangle, you have already find out d, which is what? 282 centimeter divided by r. This is diameter given. So r dash will be 0.7788 multiplied by 1.24 ka half, 0.62. Okay, and when you do the multiplication, let me see, I am getting something 12.73 into 10 raised to power minus 7. And remember, this formula will give you the answer in this unit, Henry per meter. Henry per meter. It will give you answer in Henry per meter. But what I need to find out? I need to find out in millihenry and per kilometer. So let's see. For changing a meter into a kilometer, what you have to do? You have to multiply it by 10 raised to power 3. When you multiply it by 10 raised to power 3, it can convert into Henry per kilometer. So it comes out to be 12.73 into 10 raised to power minus 4 Henry per kilometer. Now for millihenry, I guess this much. Okay, if I am not wrong. Millihenry per kilometer. Right? Say millihenry per kilometer. The answer is option B. Answer is option B. Correct, Bablu. Correct, Prabha. Correct, Electrobot. Correct. But remember, this formula I am able to use because of this line. If this line is not given, then inductance will come out in imaginary term. But that type of question will not come in an exam. Now, what will happen in case of frequency? What will happen in case of frequency to the skin effect? So again, I am going to explain you some concept about the skin effect in this question. I am going to explain some concept about the skin effect in this question. So everyone attempt it. I know you will give the right answer because I just explained you the concept earlier. Okay, so let's see. The time is less, so I am going to give you answer. The skin, if supply frequency increases, the skin effect will also increase. The skin effect will also increase. Now why? Let's see this page very carefully. What is the meaning of skin depth? Skin depth. Let's suppose this is my round conductor. This is my round conductor. Skin depth tells you the distance to which the current will flow from the surface of a conductor. This is the surface of a conductor. Let us suppose this is the skin depth. This is the skin depth. This is the skin depth. It means the current can only penetrate from here in this area. The current can only penetrate in this area. So what will happen if you increase the frequency? If you increase the frequency, the skin depth is going to be decreased. It means if I increase the frequency, then what will happen? This skin depth is going to be less. This skin depth is going to be less, and what happened? The skin effect is increasing. So always remember what is the question is asking. If the question is asking about skin depth, the answer will be it will get reduced. If the question is asking about skin effect, the skin effect will increase. Now skin depth का formula क्या है? It is equal to under root of rho pi f mu. Okay, where rho is the resistivity of a material, it is going to be constant because you are not going to change the material. F is the frequency that you can change. Again, permeability constant is going to be constant for a particular material, but it is only frequency that you can change. So if you are changing the frequency, skin defect will change, and inversely your skin effect will change. Okay, Shakil is asking, sir, what would be if there is a capacitor instead of inductor? Beta, in which question? In this question you are asking? Shakil beta, can you tell me in which question you are asking about the capacitor? In the last triangle question, yes or no? And everyone, understand the skin depth, understand the meaning of skin depth and a skin effect. Skin depth tell you the penetration effect of the current कि कितने level तक, कितने depth तक आपका current penetrate होगा. Okay, and skin effect is nothing but it's the overall name of the effect that is going to be happen. Okay, so Shakir is asking one question: what will happen in case of a capacitor here? So beta, in case of capacitor, this is going to be same. This one question is going to be same, but if I want to find out the capacitance here, the formula is 2 pi epsilon naught divided by ln d by r. Here always remember we use the radius, we don't use the 0.7788 multiplied by r. Okay, so here you can find out the capacitance, and again it will be farad per meter. Next question. Next question, everyone. Okay, Shakir, got the concept? Yes or no? And guys, like the session, and this session ko you have to share this session with your friends so that they can see the recorded lecture. And tomorrow also on the same time, 10 p.m. I'm going to take the part 2 class, and in that class I'm going to bring question on fault analysis. Okay, fault, protection, and your insulators. In these particular topics, I'm going to bring the question tomorrow. So be on time at 10 p.m. and I want more students tomorrow than today. Okay. So like everyone solve this question. Ring main distribution system is preferred to radial system. Why? Okay. Dave, Priyam, Yashwant has given the answer. Good. Everyone gave the answer. So guys, you know we have a few distribution system. First one is ring main. First one actually is radial, basic one, radial, ring main, and finally we have interconnected system, which interconnected system which include both ring main and a radial. See what happened in radial. For example, radial is this type of connection. Here you are giving the supply, here you are giving the supply, and here the load is connected. So what happened in case of a radial, the load which is connected at the end of a line will get the disturbed voltage, or you can say the supply is not very proper. For example, you are giving a current of 20 ampere here. Here it is getting a 2 ampere. Here it is flowing the 1 ampere. Here it is flowing the 0.5 ampere. Now whatever the current is left, it's going to be the last load, even if they don't require that current. So radial system is that type of system, but the advantage of this system is that it is a cheap. Okay, that's why it's going to be used in a small area. But disadvantage is that the supply is not reliable. Why supply is not reliable? For example, let us suppose the fault occur here. Let us suppose a fault is occur here. So if the fault is occur here because of this particular load, so what is going to happen? There is no supply for this other loads. Okay, जो आगे वाले loads है, the loads which are forward to this particular fault, there is no particular supply to it. But what will happen in a ring main distribution system? Let's suppose this is supply. Here we have a different load. Here I have a different load. Now let us suppose the fault occur. Let us suppose the fault occur here. If the fault occur here, so what will happen? this particular load, and this load is getting the supply from the generator. It may happen the supply will be less. Okay, it may happen the supply will be less. Okay, but there will be a some amount of supply, so that it will not get that much effective. So in ring main distribution system, supply is more reliable. Now next point, ring main is less expensive. No, ring main is more expensive. Voltage drop in feeder is less. Wrong. Voltage drop in feeder is more in a ring main system. Next, power factor is higher. No, power factor will be higher in case of a radial system as compared to ring main system. Okay, and this is the disadvantage. This is the disadvantage of ring main, that power factor is going to be reduced. So remember this point. If they ask you the disadvantage of ring main system, the disadvantage is that the power factor is going to be reduced. But what is the advantage? Supply is more reliable. Next question. Next question, everyone. Take this question in your homework. Okay, I want answer for this question for your homework. Take this question for your homework. Take the screenshot. Take the screenshot. I'm going to give 5 to 6 questions for the homework. So this is the second question. So take the screenshot. Fine. Take this question in homework also. Tomorrow I will discuss the homework. Okay, so don't worry. But I will only discuss the homework if you give the answer in comment section. If you will not give the answer in a comment section, then I will not going to discuss this homework question. So take third question, this one also in your homework. Okay, take this fourth question in your homework. Okay, and again I am repeating myself, but I am again repeating myself. I want answer in a comment section. If you will not provide the answer, I am not going to give the solution for this question. Now tell me answer for this question. It is very simple now. See, now we are talking about the surge impedance. So the surge impedance of 400 km long overhead transmission line is 400 ohm. For a 200 km length of the same line, the surge impedance going to be same. Why? Because the surge impedance is not going to affect by the length of a line. It's going to be constant. It's going to be same for this particular line, 400 ohm. Surge impedance only affect by the inductance and the capacitance. Okay, correct. Electrobot is correct. Prabha, option D, for which question you are giving the option D? Okay, last question for today's class. Last question. The insulation resistance of a cable of a length 10 km is 1 mega ohm. For a length of 100 km of the same cable, what will be the insulation resistance will be? Tell me. This is the last question for today's class. Then I will going to give 2 questions for homework, and that will make the 6th question for your homework. That will make the 6th question for your homework, and I need answer in a comment section before tomorrow's class. The insulation resistance of a cable of a length 10 km is 1 mega ohm. For a length of 100 km, what will happen? Remember this thing. This is the insulation resistance. In case of a insulation resistance, it is inversely proportional to the length, whereas the normal resistance is directly proportional to the length, but insulation is inversely proportional to a length. And this question has been asked in many AE exam, as well as in the IES exam, as well as in a GATE exam also. That's why this question is going to be very, very important. So what is the insulation resistance in first case? It is 1 mega ohm. Okay, divide by R2 equal to, it is for 10 km. I need to find out 100 km. Okay, just division, nothing else. So R2 comes out to be 0.1 mega ohm. Option C. Option C. Everyone is correct. Good. Last question is given. Last question tha, and everyone is given the right answer. Good, bacha. So beta, I can feel that your basics are strong, but they need more brush up. And the exam is near. If you're giving the Vizag exam, even if you're giving the UPPSC exam, which is on same date, the exam is near, beta. Okay. And for both of the exam, the level of exam is going to be same. Okay. So you have to brush up your basics very, very well. Okay. And don't worry, in exam, they're not giving you the lengthy numericals. Okay. There will be a numerical, but that will be very, very less. Okay. And the level will be very, very easy. Okay, guys. So take care. I hope you enjoyed the lecture. So tell me, did you enjoy the lecture? Did you learn something? Okay, did you revise the concept that you already know? So tomorrow on the same time, I want everyone to be here, and you will bring more students, more of your friends, so that you can revise the concept. Shakir, machines classes has already been taken in the last 2 days. Okay, on the 6th and 5th December, machine class has already been done. The video is uploaded on this channel. You can watch that video also. Okay, guys. So take care. Bye bye. Good night. Love you all. See you tomorrow. And keep studying. Bye bye. Take care.